Let's discuss question number 17 from test 3. This is again from manufacturing. Okay, so what is given? Well, a cylinder is turned on a lathe with orthogonal machining principle and the speed of the spindle is 200 rpm. So remember the orthogonal machining speed of the spindle is 200 rpm. The actual feed is 0.25 mm per revolution. Then you have the depth of the cut 0.4 mm. Then you have the rake angle is 10 degrees. The shear angle in the analysis is phi, which is 27.7. And what is asked is thickness of the chip produced. Okay, so now we need to analyze basically the orthogonal principle. Now you have a spindle which is basically, let's say this is the cylinder which is kept on the spindle, and this is rotating like this. Well, your tool is something like this, right? The tool is held on fixed thing. Okay, so this is, so when it rotates like this, you have the material moving in this direction. Okay, so this view, most of the time it is drawn in this way. This is the material movement material movement motion. So the same thing, this thing I'm just drawing it, and this is your tool. Okay, and this is how it, so this is something like this. Okay, so this is your tool, and material moves here, goes back here. Okay, so this is basically the depth of the cut, like the depth up to which your material has, I mean the cutting tool has, you have to the depth is basically how much depth you have to remove in one turning operation. So that is your depth of the cut, which is T1, and T2 is your thickness of the chip produced. So this is T2. T1 is your depth of the cut. Okay, that is what you need to remove in one turning operation. So it's something like this. I mean, though I have drawn it in a way. So your tool is like this, and this is your thickness produced. So this is T1, and this is your T2 thickness produced, and this is your tool. This entire thing is tool. Okay, these are your tool edges. Okay, so now we denote R as T2 by T1. We have a relation which relates the rake angle, or basically the shear angle with the rake angle and this R thickness ratio. We have that relation tan phi as R cos alpha. So R cos alpha by 1 minus R sin alpha. So this is the relation which relates the shear angle with the rake angle, where R being your T2 by T1, the thickness of the chip. So shear angle is given, so I can just write tan 27.75. Let's find R in this relation. Everything else is given. Cos alpha is 10 by 1 minus R sin 10. So from this I can just divide numerator and denominator by R, so you will get cos 10 by 1 by R minus sin 10 into tan 27.75. So from this I can get 1 by R, or directly I can get R. So when I calculate using this, I get 0.4881 from this. So R is T2 by T1, which is 0.4881, and so thickness of the chip produced T2 is 0.4881 into T1, which is depth of the cut, which is given as 4 mm. So this comes out to be 0.1955 mm. So the answer is 0.195 mm. Option is C. Thank you.